Miguel Rodríguez Artacho es profesor titular aquí en la UNED. Él está integrado en el grupo de investigación de Learning Technologies and Cooperative Systems dentro del Departamento de Lenguajes y Sistemas Informáticos en la Escuela de Ingeniería Informática de la UNED. Y desde 1999 participa activamente en grupos de estandarización de tecnologías para aprendizaje, como son el CEN LTWS, ISO JTC1 y SC36, y además es secretario, comparte secretaria técnica del organismo español de estandarización de Learning AN, JTC1 y SC36. Miguel. Sí, eso funciona, sí. Como tú prefieras. As you prefer.
I continue in English just to have the all presentations in
English, yes.
in English. So I'm going to talk about some approaches for content creation and how to handle with knowledge representation for education, educational content. So the first thing that we can address is that authoring an educational content is something more than putting together some pieces in terms of plain learning objects or just arranging information in a plain basis. So it's something that we have to think in terms of providing abstraction and providing resources. Of course, when you talk about abstraction, you're talking about how to model different kinds of knowledge and arrange it in a meaningful way so that both computers and humans can understand what's going on inside. So these are, in our opinion, the pieces of the main pieces of authoring educational content, and we are going to snapshot or to have a look to some of the representations that we have dealt with in excuse me, in some research projects here and in our group at UNED. And what are the solutions that we found for them? So the first part I'm going to talk is about this modelization. We are going to deal with a lot of strange things in education. So different people would like to put different kinds of information inside what we would understand by a learning object. We have people that just want to arrange simple a linear, for example, a linear course. So you just put learning objects one behind the other, and you have a linear path to have your learning. But some other people are thinking on these things that I have here, like social constructivism. So we are involving groups, and we are involving complex interaction between the people in the group. We are also dealing with feedback from a machine, like in an intelligent tutoring system. So we have a lot of things involving education, and everyone, maybe you get two different teachers and they don't have in mind the same things. When you ask them how are you going to teach, or what are the things that you would put in your specification to teach some material. So the idea is to modelize all this information in a domain-specific language. That acronym means domain-specific language. So, in fact, those are the e-learning specifications. So we are trying to modelize something, and for example, one of the things that we use, we will see later an example, is XML. XML is a good language to modelize some specification, and we can put a lot of information inside. But we will see that we are going to mix different kinds of information at a different abstraction levels in the same specification, and that makes specifications to become very complex to understand by humans, and also to be deployed in the virtual learning environment. So that's the tricky thing that we have to deal with. So one of the approach that we can get to modelize content is this one that we can show here, which is based on maybe these two steps, which is On one hand, we can make domain models. So let's put the content or let's put the domain isolated, and let's modelize the domain in such a way that we could later retrieve and access that information, which is knowledge, not information itself, is knowledge about a content matter in a meaningful way for educators. That means that you are not only provided with the knowledge representation, but you are also provided with the meaningful way to retrieve that knowledge in an instructional way. So on one hand, we need domains, and this is some complex things to do because it's tricky, it's complicated to modelize a domain, and also it's very complicated to populate or instantiate that domain with actual information and to be reused. Okay, so we have the domain, and we need another information, another piece of the model, which is the instructional strategy. So that's why I say that two teachers, they don't think the same way, and they are going to be very different in the way they understand the teaching process. So those instructional strategies are different between two people, and we need another explicit representation from that. So those are in the last sentence has the way we have to organize these two kind of different knowledges from the instructional point of view. On one hand, the domain, we can organize it using an ontology, and we can populate the ontology with a domain model. And also, we can use instructional templates, which are formal specifications. They have an abstraction level in the sense of they have in this abstraction level, we explicitly incorporate an instructional theory in the terms of we can have an instructional perspective, and we can create this instance to hold this instructional perspective, and we can put these two things together. So the thing should be to have the ontology and have the instructional template, and think how from the instructional template we can access the information in the ontology, and how can we deploy all this instructional experience in a virtual environment. So this is an example of what we understand by a very simple instructional ontology. For example, we can modelize a scientific matter in this way. We can have, for example, concepts. We can have examples that illustrate concepts. We can have a problem that makes a drill and practice over those concepts, and many more things. For example, we can have hints to facilitate students to solve the problem. And we have reflexive relationships like prerequisite, so we can have concepts that are necessary to understand another concept. So this is the shape of instructional ontology. How can we access this knowledge from specifications? I can give you this example. For example, we are trying to learn about iterators in Java. So we could, let's say that we have instantiate the concepts with current content about iterators, about Java, and about examples, etc. So we have many instances of each one of these entities in the ontology, and then we can say, okay, we are going to make an instructional query. We are going to use the relationship illustrates. We are going to, let's say we are in our conceptual domain, excuse me, and we are going to retrieve examples where iterator is the concept in this relationship. So what we are going to do is to fix concept as its iterator, and then gather all the illustrate relationships that are pointing to the concept of iterator in Java. So it's an example of how to retrieve content from a domain modelized in form of an ontology. So this illustrates a way to have an abstraction and a way to have these levels of abstraction when modelizing content. Okay, the other example that we can have is a concept map. In an ontology, we usually are in charge of populating the ontology and to making the ontology grow with our knowledge, and usually this is the tricky thing to do when you modelize content this way, because it's a lot of effort. When thinking in concept maps, we can think in students participating in groups and creating their model of an activity. This is an example of a project of a collaborative group creating their own model when exploring some activities in an open air. There was a project for high school students for learning nature. So they were to Monte del Pardo, and they had to make there some activities related with identify some plants and label the plants and study the relationship between animals and the climate and whatever. So they are building knowledge, and they are building explicit models of knowledge there. So this is another example of the kind of thing that we can do when modelizing. So knowledge is one part, and the other part, as I showed before, are these instructional templates. So if we have, if we say that it's complicated and tricky and a lot of effort to populate an ontology with a domain model, we can also say the same for instructional templates. First of all, because we need to create the specification. Usually, the specification that we have in mind in this field is learning design. Everybody knows IMS learning design as an example of a template to organize teaching with the metaphor of a theater play. So we have actors, we have roles, we have people involved, we have processes and resources involved, and we can create the experience of explicitly define this. When I say instructional template, I go beyond this step. So I think what would do a teacher or an instructional designer with this particular instructional theory? Maybe he can have his particular way to teach students. So what I mean to say is that on top of a plain specification or a neutral specification, we can have a battery of instructional templates that implements certain instructional theory. And explicitly they implement this theory, and we combine the instructional template with the domain knowledge, and we have an instance of a course. We can provide this abstraction if in the implementation using some abstraction levels. One of the most simple abstraction levels that we can get, we don't need to go far away because we have them in the IMS stack of implementation. For example, some of the aspects, some of the entities in the XML model of content packaging are dealing only maybe with structure and content and accessing and organizing that, but with no information about how to sequence or which content is a prerequisite for another one. So we need another specification in order to handle those that abstraction level. And these abstraction levels are supposed to be the things that a teacher has in mind. So when we think on teaching, we are all the time having this in mind. I want to sequence my material, I want to provide this resource, I want the students to be dealing with the resource until they get some skills, and then after that, maybe I assess them, and then they perform a task, and then I go further in the curricula. So this is an example of when I talk about abstraction level, what are the things that we have to provide to specifications. So in putting all these pieces together, we will have this axis that is an axis that can be written from top to down and from right to left. So going from up and down, the first step that this instructional designer has to do is to organize the content and organize the abstraction level of the content matter, and also organize the instructional templates that are going to be useful for the teaching. So it would be nice to be provided with these instructional templates in order to select, for example, different kind of experiences for our students. I'm not going to say that this is something that goes in the instructional theory I mean, we don't need to go very far away to achieve this goal. We just need to go to our institutions. In our institutions, in all our universities, we have plenty of experiences that we can do with our students. For example, in this faculty, psychology, maybe they experience more with groups of students, and they address some kind of different activities done in a computer science school, for example. If we go to the chemist faculty or the physics faculty, we will have the same. So every institution has a battery of instructional templates that usually are the kind of activities that they are performing in their courses regularly. So we don't need to go to a complex instructional theory or something like that. So we just have to have our knowledge arranged in such a way that we could retrieve it from an ontology, and then our instructional template to access that knowledge and then instantiate them with the current subject matter that we have. For example, we can instantiate our ontology with a Java course, and then instantiate our template with a current subject that starts in June, or starts in September and finishes in June, having these some activities. So that is the picture. As an example of how complex or not how complex, but the kind of things that we can find in a specification, all of us knows about the IMS and usual standards, but we can have here a simple example of kind of an activity, which is this is the definition of a laboratory. This is a specification that we did here at UNED to perform remote laboratories with students, and the idea was to provide both activities, resources, and students and people involved in the same specification. This was done some time ago, and what I want to show is that, for example, if you go to the learning design specification, or you try to read this specification, which goes, I don't know if you see the cursor here. Yeah, this is a definition of a lab doc, which has one experiment, and the experiment contains one activity or maybe two activities, involving some tools, some roles performed by the students. So what I mean is that we don't differ very much from, I mean, we are all the time modeling the same things. So what we have to have in mind is that the different elements that we have we have in mind to be modeled are more or less the same. Now, in this morning and yesterday, in the meeting we had about standards, one of the things that we were talking about is that it's time to reshape some of the specifications that have been done in the last years. For example, one of these specifications is the paradigm of how to describe a learning design, and there are people now working on new ways to reshape this. One of the examples could be this one developed here, and the idea is that we have to say that it's complex and it's tricky to work at that level of abstraction. So I'm going to talk now about resources. So I've been talking about modeling, and now I'm going to talk about resources. So that's the other part that we have to take care about. Not only when I talk about resources, I talk about repositories and metadata, but I talk about general or content organization that can be, for example, the web, and how to handle with those resources. So here are the different ways that we have to have content. The first one is, of course, the web. So we don't have any structure there. We just go there and search using some search engines. Others are repositories, which can contain metadata or can be hierarchically organized. The third one could be this ontology that I showed to you, in terms of they are organized in a semantic way. The first two, which is web in a general way and repositories, can be accessed using harvesting technologies and search and retrieve URLs. So these two techniques, and there's another one missing, which is OER, which is another technique to group and to organize the retrieve harvested information in terms of a group of similar resources that share some common definition. So here we have an example of something that have been proven to be very useful. We go to a repository, we set up as a target, so we show all the metadata in the repository, then we gather the metadata, we can query that and retrieve the elements. So what we have here is some balance between a very precise search going directly to the URL, obviously, and the other one that can be very effective, but maybe using this harvesting, what we call recall, means that maybe we can be very, very exhaustive, retrieving everything that is interesting, but we can only be also very ambitious. So maybe we retrieve something that we don't need. So that is the balance between going directly to the URL and going to the harvesting technology. Without the control of having metadata, what we have is just to search in the web. So in this case, we don't have very much control. So sometimes we are going to retrieve something we don't care about. We only have keywords to make the search, so we are also limited because we cannot make a very complex search in terms of avoid. Well, we may say avoid this website or go only to this website, but we cannot structure the results very much. So that's another example of. So okay, we are in the resources part. We have moved to the structured one and to the non-structured one. I'm going to put you just to finalize an example of a project that we are now taking in our department that involves non-structured resources to get learning resources and learning objects to our authoring tool. So what we are going to do is to use one technique of the information retrieval field that organizes the content in the form of a lattice. So you go to the web, you gather all the information, but then using this technique, you can segregate and cluster the different results in terms of a network or a lattice and we are going to show later this tool working. The overall picture, we will take a look to the overall picture of the project, because our intention is after we gather those resources, we apply some instructional intention just to select the appropriate ones to be delivered to the student. That's why we talk about the Bloom's taxonomy and some other instructional classifications just to make these resources available to the students. So we combine these 4 technologies that I show here. We use information retrieval techniques to make the clusters and to crawl the information inside the web. Also, we have ontologies to modelize the instructional intention and to classify these learning objects according to the possibilities that they have to be useful for the student. And also we, finally, we have our own repository, so we can store the appropriate information in a regular repository with at least some metadata that we can make automatically. So this is the picture of the 3 steps of the classification of the resources for the student. So